Okay, we are back. I had a good time going out. So I'm back, and now move on to chapter 3. Chapter 3 is nice. We are going to learn the keywords that. So yeah, all the programming language will have the keywords that is reserved, and you can't really use it for other things because they have special meanings. So you can use it casually. So you find out the list of keywords. I'm not going to. I'm just gonna learn all this thing I need to learn on the go. So let's see. Ooh. Storing values with variables. Okay. Immutable. So okay, so now we have it's very confusing. So we need a new project called variable. So okay, we're gonna do that. We're gonna do this again, going back to our main directory and do cargo new variables. It's very difficult to spell for me. Variables. Okay, so let's go. We're there, and then the main.rs. This time we're gonna do this. So let's do this. Or can I click on it actually? What is this? What are you doing? This code does not compile. Okay. This not panic. Or this code is not produced. Interesting. Okay. So we'll have an error for this. So be prepared. That's what it says. Okay. Let's collab this and go to variables, go to main, and then make mistakes. That's what we do. We learn by making mistakes. So if we now go back to our terminal and say I want to run or build, actually build will fail as well because this code does not compile. Yeah. So yeah. Because x is not mutable, we can't assign it twice. I think this is what it is, but let's see what's the official explanation of this. Cannot assign twice to mutable. Exactly. So because it's not mutable, it's immutable, so you can't assign it twice. So the program will assume that there's something wrong if you do it twice, like assign it twice. So you have to change it to mutable, then it will compile. So let's do mut, and save, and do it again. This time it should compile. It should be fine. If we do run, then it will just do whatever it is doing. Yeah. Okay. Right. So yeah, constants, immutable variables, constants of values. So there are so constants are a separate thing from immutable variables. So I guess they're very similar, but they are also conceptually different. Constants are variable that are bound to a name and not allowed to change. A few differences. Yeah, there are some differences. You aren't allowed to use mu with constants. Of course, constants are constant. You can't change them. Yeah, so it's not just immutable. They are always immutable. They're not just immutable by default. They're always immutable, so you can't use mute. So you use const keyword instead of let. Yep. Declare in any scope. So and the type must be annotated. So variable, you don't have to. For example, this one, it just doesn't say that 5 is in I32 something like that. Is not. So yeah, so but constant, you have to declare the type, annotate the type, and we can declare in any scope, so you can make them global. Maybe set only to a constant expression result. So you can also assign it to an expression. Not the result of a value that could only be computed at runtime. Yeah, so you can't just say, x is 5 and then some constant depending on x. You can't, because it need to be a constant expression. So this is fine because this is constant. No matter what you do, it's always 60 times 60 times 3. This is fine. Yep. Constant is used to all uppercase. So if it's all cap, then it's a constant. Normally, because that's the convention. Compiler is able to evaluate a limited set of operation at the compile time. So this will be evaluated at compile, I guess. Yeah. Write out this value in a way that's easy to understand. So, for example, like 3 hours in seconds. So, like instead of pulling out your calculator and calculate it, and no one understand what are you doing, just write it out like this. And then when the code gonna compile, it will already do the arithmetic. So it's it's there. So you don't have to do it like manually. So the compiler will do it for you. Yeah. Available for the entire time. Program runs within the scope. Okay, hard-coded value used. Yeah, so if anything is hard-coded that is used throughout the program that hasn't been changed, then you can use constant. Only one place in your code. Shadowing. Guessing game. We have a thing. New variable with a name, a previous variable. Huh. Yeah, so what was that? Guessing game. So if we look at it, like guess here, yeah, we have declared twice with the same name here. Can say that the first variable is shadowed by the second. Second variable is what the compiler will see when you use the name of the variable. Overshadow the first. So this can shadow a variable by using the same variable name and repeating the use of the let variable. So yeah, I guess like you just overwritten it, right? Because the first variable is shadowed by the second, which means that the second variable is, well, let's say when you taking any use of the variable named itself until either itself is shadowed. Yeah, so it's like, yeah, so it's just overwrite the previous one. So this one, so it's 5, is like this was 6, right? First line you got a 5, and then one's a 6, now it's 6. So hit the inner scope created. So now it's 12. So this was 12, but outside the scope is back to being 6. So if we run this, then we would get, let's close this and then go here. So we get 12 and then 6 because this one is only valid within the scope, right? So okay, yeah, we got 12 and 6. So yeah, so this is interesting. So this is kind of similar to what Python do, I guess. So it's, yeah, different from make a variable as mute because we get a compile time error. Yeah, so if we don't use let here, then it will have an error because we assign x twice in this scope. So I guess if you do this, then you would get an error. Yep, exactly. So don't do that. Don't do that. Shadow is different from, yeah, mute. The difference is that create a new variable and shadow the name actually. Then change the type. So you can change the type. So now it's like this is. Oh, I can click this. So yeah, running. So this is a string apparently, and then this become an integer, so that the type can change. No output, yeah, okay, of course. So, but if it's mutable, then we will have an error for this one. Oh, yes, this one will panic. Oh, okay. Yeah. Yep. So because we changed the type, so if you let so that means that you create a new variable, you can change the type because it's a new one, it doesn't care. But if you use mute, then you assign it to a string, and then now like you're supposed to only mutate the value, but not the value, but not the type. So if you change it to another type, then it will panic. It will panic. Yeah. Okay. Move on to the next one. Data type. So data type is fun, I guess. It is something that like Python people don't care too much until recently. So, yeah, let's have a look. Type annotation, we love that now, isn't it? Like, yeah, now we can say that this is unsigned 32 integer. So it's 42, and then parse, and then expect not a number. So this is a string, right? Like 42, and then you pass it. It's supposed to be a U32. If not, then there's an error. There's not a number. If yes, then I guess it's got assigned. This is what happened, right? Oh. So if we don't add the... what's going on? We must add a type annotation like this, because we use parse. If we don't do give a type, and then... yeah, if we don't do that, then we will have problem, because then parse don't know how to parse it. Yeah. Okay. So can I change it into something, and then... oh, no, we can't. Okay. Scalar types. So there are different types. And there are scalar types, which is a single value. So Rust has 4 primary scalar types. So they are integers, floating point numbers, boolean, and characters. These are scalar types. So I think it's the contrast to something that's an array. So that's why it's a scalar, just one value. So it could be numbers, integer, floating point numbers, which is a special type of the number because you've got a decimal point, so it's different. The boolean, so yeah, it's like in Python boolean is actually integer, but I guess in Rust it's different. It's like another scalar type, and characters. Yep. So how they work in Rust? So integer type has different length, so it's with a functional component. It's just plain numbers. Yeah, U32 type. So unsigned means like it's there's no negative value, so there should be unsigned integer. So those that you can count, like 1, 2, 3, 4, 5, things like that. Then I got some comment. Hello. Oh, you can edit the code example. Thank you. Press on the button in the top. Ah, that's good to know. Let me have a play. Okay, can I change it? Can I change it? Can I change it? Oh, it's copy. How can I? Sorry, let me double check. If you press on the button at the top right of the code block, there's a button to run the code on the playground. This one? Ooh, yeah. No, it's not. It's just hiding some unnecessary information. I can run it, but how I can change it, I still don't know. Sorry, I'm very dumb. Maybe I can change it somewhere. It's fine. We'll figure it out. We'll figure it out eventually. But thank you for the tip. I would try harder next time. But yeah. Okay, so they are unsigned and signed, so let's go back. Okay, so if it's signed, it's I for integer, I guess, and then unsigned is U, for unsigned. So things you can count are unsigned. So signed, I guess, is like because it's negative, so you have the sign. So let's take up 32 bits of space. Yeah. So if, for example, like U32 is take up 32 bits of space because nothing, you don't care about the sign. So all of them are used to, for the integer. How many bits of space? So we need to type in Rust. Right, so we can go from age normally to 128, and there's something called arch, which is, I guess you can have a custom size, yeah, but I think it's rarely will go to that big or small. Yeah, whether it's like negative. Yeah, if it's unsigned, it's only positive. Yeah. Yeah. Okay, so yeah, also how big it can be. So it's like 2 to the power of something. Yeah. Architecture. Oh. Okay, so this is like the architecture of your program. This is the biggest you can do. So yeah. Of your computer programs running on. This is a little bit of like a flexible thing. Yep. So it's using whatever the computer, like which computer you're running on is whatever it is using, then it will be that size. So it's architecture. It's the last one. So yeah, the button is this different. Is okay. We can always copy it to our editor and run it if we want to. It's okay. Yeah. So right. Unsigned that. We can also write an integer like that. So this is 57UH. This is very funky. Any form shown in that. Notice that the number literal that can be multiple numeric type. Whoa. Visual separator. So yeah, this is like 1000 actually, but you can make it easier to see. So yeah, so this is really cool. So I think this is also available in Python, but like in recent years again, like so for example, we have decimal, we can have this hexadecimal, so because like you use the X, so it's like the hexadecimal, how it looks like. So number literal, so all of these can be recognized. You can write in binary if you really fancy. Octal, byte, UH only. I'm not quite sure. This is byte. So I think it's the character A that got like represented in byte. This is what it is. Yeah. Cool. I think most of the time we don't need to dive that deep into this, but like for some specific thing that you do, maybe you would do this. Yeah. So the default is I32. That's a good place to start. I think it kind of usually works. Primary situation, you can use I size or U size. It's indexing some sort of collection. Yeah, it can overflow. If you, for example, have a super small one, like the UH, and then you only have like 0 to 255. If you have something that is bigger, then it will overflow, which means that it will go crazy. So it's either it will check by the compiler and panic and say like, oh, you overflowed, right? Kind of shout at you. Or if you just compile it with the release, then it won't check and it won't go panic, but then you'll have some unexpected result because your number overflowed. Yep, it will wrap around and become 0 again. Ooh, fun. But like that actually, we can do a lot of fun stuff with it, but then like I guess if you're doing something serious, then people will get very mad, like why do you introduce this bug? Or because it's overflowed. Yeah. Whew. possibility of overflow, you can do something about it. You can so standard library can have something to help you. Wrapping, return the none value if there's an overflow with the check method. So you can use other method to make sure that if something overflow, you can handle it. So overflow with overflow method. You can have some check in your code. So you, like, for example, if a user input, if it go too crazy, then you can handle it. Yeah. Okay. I hope we'll have some. Yeah, there's like chapter 9 will explain a little bit more, and also like I hope there will be some time in the future we can learn more about these, but I think not now. Yeah, so let me also read the comment. Yeah. Unsize is used because of an array in this. Oh, okay. Yeah. Yeah, so that's the, like, if you use usize, because depend on the architecture, then you can kind of limit things, like, then if it's overflow, it's because it can't be handled by the specific computer that the code is running on. Yeah, there's also the online yeah, actually the Rustlang web page have the online playground that is actually super handy. I just love doing it on my computer, then I can kind of see my progress, like what have I done and stuff. So yeah, there are multiple ways of doing things as always. So let's move on to floating points. Floating points, we have f. So f32, f64. These are floating point types. Yeah. So for example, we have this. Okay, let's give it a try. We're at the variable, so let's just try it here. Yeah. Bum bum bum. Oop, we have some problem. Prefix it with an underscore. Unused variable. Oh, it's unused. Yeah, of course. We can. I guess we can print it out if we want, but yeah. Or we can just do this like this. Yeah, it should also give like no output. Yeah, it's fine. Yeah, so because you have the decimal point, there are floating point numbers. Yep. I think I've checked that standard before for other reasons, and it's a rabbit hole. It's very dangerous. I'm not going to check it now. So yeah, you can do a lot of numeric operations, plus, minus, multiplication, division, truncated division, because they are integers. So yep, they would give you the, like, because this is a signed integer, they will come back as a signed integer, I guess. And reminder, percentage. So this is quite similar to what Python do, so I'm not going to dive into it. Boolean type, so true or false. Yeah. So explicit type annotation. Yep, quite straightforward. Yeah, so you can use Boolean. Boolean type is very useful when you have the if expression, and also different from Python, it's lowercase, it's not like capitalized. Yeah, small difference. Character type, so character is a character, and you can define it. You can use emoji. Emoji is a character because it's in the Unicode, I guess. Yeah, so you can have accent character, you can have Chinese, kanji, Korean characters, emoji, all this crazy thing like zero with spaces. Yeah. Yeah, there's a range of like what Unicode is allowed, but I guess most of them is covered. Yeah. Really a concept in Unicode. Okay. Yeah, there will be details in chapter 8, so we gotta save it to there. Hey, hello? Oh. Kyle's a friend. I know who you are, and I'm glad that you're here. Thank you so much. And yeah. Very handy using. Ooh, you can use debug mode in Rust. Cool stuff. Yeah, we can do that as well. I hope the book will be teaching me in the future, so I'm looking forward to that. Compound types. So, and Rust has two primitive compound types, triple and array. So, yeah, now we're going to like outside of the scalar territory. So now we have more than one thing in your variable. There's like tuple and arrays, so which is cool. What are the difference in Rust? I know in Python like they're also like, well, in Python with list instead of arrays, but they are different. So let's see what's the difference in Rust. Tuple, a general way of grouping together a number of values. Yep. Fixed length, once declared, they cannot grow or shrink in size, so they are immutable. Like itself is immutable, but I guess you can put something inside it. You can, I don't know, like that goes to a very dangerous territory. Can you change something inside a tuple? Like it said that it got like fixed size. So yeah, it's like, you know, so in Python tuple is immutable, so I guess it's kind of immutable in a way. But I don't know whether you can kind of change what inside is like. For example, it's a mutable variable inside. Can you change it? Something crazy like that. I don't know. Comma separated list. Each position in the tuple has a type, and the type of different values don't have to be the same. So you can store multiple things. You can store like a integer, a floating point, and an unsigned integer, and they're all different sizes. Crazy. Yeah. So this annotation is optional, and so you can store different things like this, and yep, bind to the entire tuple because tuple is considered a single compound element. So tup itself is become this whole thing. So if you want to access things inside, you have to do something like that. Use pattern matching to destructure a tuple like this. Create a tuple and bind it to the variable tup, and then uses a pattern with let. So when we do let, then it will do the pattern matching and match this three separate variable into this three separate thing in tup. Destructuring, it breaks it into three variables. Yep. So this thing will give you 6.4. I'm not going to try it. I'm pretty sure it is correct. I just trust it. And yeah. So what else? Whew. So if you want to get an element, you can also use a dot to get an element. So 0, 1, 2 is started with 0. So 500 is this one. Yeah, okay. Okay. Array type. So array is square bracket is look like a list in Python. Cool. Every element must have the same type. So this is different from Python. In Python, you can store whatever you like in a list, but in Rust, it needs to have the same type. Array and Rust have a fixed length as well. So yep, so a fixed length, fixed type is an array. So, oops, I have more comments. You can change a value inside a tuple as long as you declare. Yeah, so if you have a variable inside and you make it mutable, you can change it. Ooh. Yep, you can have it more elements. Yep, so which one it works? Yeah, we can see if there's a little cute thing here. I think this explains it. Yeah, okay, cool. So yeah, an array is actually not as flexible as the list in Python. So this is cool. And what else? Okay, so you can store so the list of like 12 of them, and they are like yeah, it's like a vector. Okay. This gets stacked in a heap in chapter 4. Ooh, okay. Love it. When you want to ensure you always have a fixed number of elements, an array isn't flexible. So vector is more flexible, yes. Similar collection type provided by the standard library. Ooh, okay. So vector, you can grow in size, so you can attach more things in it, and okay. So an array is fixed length. A vector is not. Array more useful when you know the number of elements you will not need to change. Yep, this is a very good example. Square bracket, semicolon. So this is how you declare the type. So it will all be I32. There's 5 of them. Like that. Okay, you can also initialize an array to contain the same value for each element by specifying the initial value. So yeah, so instead of like 5 times, you can use semicolon and say like 5 times. Okay. Yep. It's good. Yeah, I'm sliding down the chair for some reason. I don't know why. Yeah, I have to reset my camera. I think now it's a bit too loud for some reason. I would fix those next time, maybe tomorrow. Access array element. So array element, instead of dot, we use the square bracket to find it. So again, start with 0. Name first 31 because it's using the 0 in index. Yes, 0 indexed this. Invalid access. Yep, this will panic. Okay, so what's wrong? Array index, so you type in something and then yeah. Using cargo run, enter will print out the corresponding value. Yeah, because the user input can be crazy, right? It could be outside the scope. So if you type 10, what's going on? It will scream at you. Yeah, it's out of. So there's a runtime error. So it's a runtime error because it will compile, it will run, but the user may break it in like by the user. Yep, so it will exit at the error message. Okay. Rust memory save principle in action. This kind of check is not done, so ooh, really? So in other languages, like if you index 10, it will just give you some crazy things, I guess. If you provide an incorrect index, invalid memory can be accessed. Ooh. So someone naughty can do something very, very naughty. Okay, so Rust will protect you. If someone tries to access something that's not in the scope, then it will panic and tell you not to do that. Cool. And you can also handle it because of error and stuff. So it's amazing. Yeah, so that's what Rust is well known for, is the memory safe. It won't let you to access something that is not allowed. Okay, moved on. I want to finish chapter 3 at least. I'm getting very tired. It's quite late, but let's do it. Functions. Functions is cool. Fn is the main function. We have done it multiple times. And we use snake case just like Python. Underscore. Here, so we have another function, and then you print another function. Okay, this is a little bit silly, but it's fine. Yeah. Followed by a set of parentheses, because call from inside the main function. So it's defined within the same program, right? So after the main function, so Rust doesn't care if you define it here or before. So somewhere in the scope. So they just need to be at the same scope that can be seen by the caller. So I guess main can see this because it's on the same level. Yeah. New binary function to explore function further. Okay. So this another wait. Okay. So yeah, this one should work like that. So do we need to start a new project? We have many things here. Okay, fine. It's fine. Okay. Interesting. Maybe now I can see if like I'm just making sure that I know what's going on. So this is function, right? And then now in the side functions, I have the main. I can put it here. Yep. And then now I can run it. Yeah, I guess I'm just like building my muscle memory in like how to do this stuff, which is a good thing. It's a bit silly that like you have to do it every time, but I think it's practicing. So, yep. And now we can add parameters. So another function. Okay, so now we can take an unsigned integer as a variable. So I can do that. So it's fine. Type of specified. I'm not gonna put s where the pair of curly bracket is. Yep. So print labeled measurement. So we can put the label, then. So we take more than one variable this time. So we have a character and a number. So let's do that. And then yeah, it works fine. Statement and expressions. Yeah, wrestlings. I would try wrestlings in the future. A lot of people recommended that. I think it's fun. I think it's more fun than me like reading the book, but I have to do this first. I hope that like next week then I would have enough knowledge to try try playing with wrestlings. I hope. We'll see. I have no plan for like this whatsoever. I'm just like doing it for myself. I want to learn Rust, and you have to suffer with me and watch me do this. So yeah, sorry about that, but yeah, just like if you want to hang out, please hang out with me. I love that. Yeah. So statement and expression. So, So, yeah. Ooh, now this is funky, and this one got a lot of that's cute little crap here. So okay. So this is normal, right? But this one is not normal. So function body made up of serif statement. Okay, so far we've so statement and expression. Statements are instructions that perform some actions and do not return a value. Expressions evaluate into a value, resultant value. Let's look at some example here. This one is a statement, right? You do something. It create a variable and then assign a value to a variable. The statement. And then if you do this, you get an error. Because if you do this, then there is a parenthesis and it's not good. It's not good. So what's going on? Because so this thing is a statement, so it doesn't return a value, so it doesn't create anything for x. So yeah, this is wrong. But So in C and Rust, it will return the value of the assignment. Ooh. So both X and Y will have the value, but not for Rust. Let's see. So for Rust, you can't do that. Yeah, and also the coloring is wrong as well. So I guess, yeah, don't do that. So what you can do is, for example, like this. This one, I think because the last thing here create 3 plus 1. So, yep. In Rust, math operation. So for example, if you yeah, if you have 6 plus 5, then like 5 plus 6, then it's fine. Yeah, you can do it, for example, like that. Then you won't have a problem because it's a mathematical thing. You just add up. Let's go. What have I done wrong? Ah, you should not use this. Yeah. So it's cool. And there's something else. Oh, because I haven't used it. Okay, fine. But yeah, basically it's fine. So if you do this, there's an expression, and so if I copy this and do this, it should give me the value of 4. Yes, it gives me 4 because x plus 1 doesn't have a semicolon, so it kind of executes the value. Learning Rust is cool. Yes, I'm trying to join the cool kids and learn Rust. That's what I do. Yeah. So let's see. Yeah. So this block will give you 4 because x plus 1 doesn't have a semicolon, and it will just calculate this and give you 4. Unlike most of the line, expression do not include a semicolon, so that makes it different from a statement. At a semicolon, then you will have a very sad face. So let's try. So this will give you a very sad face. Yes, it doesn't work because this thing doesn't give you a value. So y doesn't have a value, so it's wrong. So you have to remove the semicolon. Yep. Now we learn. Calling a macro is an expression. Huh. Calling a function is an expression. Calling a macro is an expression. Okay. A curly bracket, also a new scope block, also create an expression like this. Okay, cool. Function with return values. So what if we want to return something? This one will return an integer, right? So you give it 5 because yeah, it's like 5 is here. It doesn't have a semicolon, so it's an expression. So it will give you 5. No, 5 is 5. Okay, so it's just like this. You can try it out. 5 will be 5. So let's run it, and we have 5. High 5. Yes. Right. There's no function called macro or even let statement in the 5 function. It just gives you 5. Yes. But we have to use these arrows to say that okay, we're returning a number. Cool. And second 5 function have no parameters. And define the type of the return value, but the body of the function is only 5. Okay. What if we do this plus 1? And plus 1 will take the parameter will take in any integer, a number, and return another number. So this one will give you 5 plus 1. Oh, I see. Oh, not here. Okay, I thought this one doesn't work. Like, why? Okay, no, next one doesn't work. Okay, so let's play. Okay, so like yeah, 5 plus 1 is 6. So we are getting the right answer. So what if we do something like that? This one have a problem. Oh, I know. You put a semicolon here, not to you. So this will give you a set face because, yeah, this is a statement, it's not an expression. So you don't have a value to return, and it's wrong. So you can't do that. So you gotta set face. Yeah, it won't complain because you use the underscore to say that you won't use it exactly. Yep. Next one is comments. Comment is simple, right? Just like double dash. I guess we don't have to spend too much time on here. Cool. Yeah, you can add multiple lines, but each line you have to add the slash slash. And you can add it at the end of the line. You can add it inside a function. Yeah. Cool. Yeah, I guess I would skip until we have to use comment for documentation. And control flow is if else, if statement. Cool stuff. So now, what do we have? Branches in your project directory. Okay. We create another project. I'm collecting them all. I'm going to do that. I'm going to collect them all. It's fun. So, okay. So cargo, new. So this is called branches, right? So we are in the branches, and we have a new branches here. We have a main dot rs, and now we have a new things. So let's put it here. Oh, nope. Yeah, cool. And number equals to 3, and then number, if number is less than 5, then do this and that. Okay. So I think it will run. I have faith in it. And the condition was true because it's less than 5. Yep. So this is also quite straightforward to know. Yeah, if else statement, we have this curly bracket. This is very similar to JavaScript actually, with the curly bracket and stuff. So yeah, so this is cool. And are there any special things that I have to learn? So we have a true or false. So this will become true or false depending on the number. So these two are called arms, I think. Yeah, just like the match expression. Yep. If we change to 7, then it will be false. What if we change it to something else? I think we are going to try that soon. Like, oh, what if the type doesn't match? What happened? So yeah, the condition was false. Okay. So if what's going on here? Must be a boolean. Okay. Okay, because this is not a boolean. That's why we have a set. We will have a set face. Because not a true or false is a number. We are expecting a boolean, so we can't do that. We can't. So we have to do it like that. If it's equal to 0 or not. If it's not equal to 0, then number of something other than 0. Alright. Okay. Handling multiple condition using else if. So we just spelled it out, else if. Okay, so there's dividing things. Yeah. Using too many else if expression can clutter your code. So maybe you should use match instead. Very true, very true. Yeah. So if let, so condition equals to true, number equals to if. Whoa, this is funky. Let's copy it and run it and then have a look. The number is 5. Is like, because if condition, then 5, else is 6. So we got a 5 for a number. Yeah, so you can condense the if statement like that, I guess. And also because there's no semicolon here, it will return the value 5 here. Got it. Nailed it. Ooh, else is 6. Can I do that? Can I do that though? Yeah, I think we have a problem here. If we do it like that, being very naughty. Yep. It's expecting an integer, so you can't do that. Which block of code executed value have the potential to be any arms within the if. Both are I32. If the types are mismatched, then we'll have an error. So all the arms should return similar type. Same type, actually. The string won't work. Must have a single type. Need to know at compile time. So it needs to know in advance that what type it is. So that's why it needs to be the same type. Otherwise, the compiler will shout at you. So you can't do that. Yeah. Compiler would be more complex. Yeah. So yeah, this is very different from Python. You can't have a variable that can be anything. No, the compiler need to know. So if your code doesn't show what it is, it could be anything, then there is a big no-no. Repetition with loops. So we can have loop, we can have while, we can have for. So loop, I think it just loop infinitely. Over and over again forever. Until you specify, or until you stop it. You type like stop, and you stop. So this, I'm not going to run this again, and you have to like try to stop it, like Control C or something. Oh no! No, I don't want to give it a try. It just looks very scary. It would just wash my whole screen with again. You press Control C. You may or may not. It depends on whether you're fast or not. No. You can place the break to break free. Yeah, or use continue. Skip over any remaining code and go back to the starting point of the loop. So I think there's a more reasonable thing. So every time it increases the counter by 1, and if it counts to 10, then it would just break, and they will give you 20 times the counter. So, 2 times the counter. They will become 20. Yeah. Okay. Let's try research 20. Exactly. So, yep. It breaks, and then you can return a value, I guess, and then it will give the result. So this is result. But interestingly, there is like a semicolon here. I guess because it's break. So break have a semicolon, but this is the result that got returned. Okay. Break after the loop, we use a semicolon and the statement that assign the value to result. Interesting. This is a bit confusing because normally if you want to return something, you don't use the semicolon, but because I think it's because it's break, then you have to do that. Do it like that, I think. Yeah. Loop variables to disassemble between multiple loops. Ooh, this is getting more complicated. So counting up. Loop within loops. Innermost loop at some point you can optionally specify a loop label. So you can give it a label so it's easier to see, I guess. And use break to continue specify those keyword. Interesting. This will make this will make like dry running the code super complicated, I guess. Because not always the inner loop, you can control the outer loop as well. So count is 0. So counting up. So this loop is called counting up. So the outer one is called counting up. So it will print out the count. Then it will create a remaining, which is 10. It will create another loop. So remaining is, if it's equal to 9, then it will break. If it's 2, then it will break the counting up. And it will just -1 for the remaining, and counting up. This is a bit complicated, and yeah, let's see. So it starts with count equal to 0, and then remaining is 10, and then remaining is 9. Then it break. I guess it break the inner loop, so it go out again, and then now count is 1. So count is 1, and then 10, 9 again, and then count is 2, and then now the so because remaining, so first remaining is 10, right? So the first time we go through, then it see that, oh, it's 2, so we break the counting up, so it kind of stopped there. And yeah, yep. So this time, like, it's 10, 9, because 10, the first time we see the count, so it's ended at 2. Whew. Yeah. That's the label. Counting over counts. Doesn't specify a label. So in loop. Yeah, I think this is closer to like machine code that you just like control it instead of having a condition like while. So while the condition is true, it will keep running. When the condition ceases to be true, so when it becomes false, then it will break itself. Yeah, so you can use loop, if, and break, but I guess this is less mind-blowing than the previous one. As number is 3, number if not 0, then print out the number if it's like it will decrease, and then if it's not, then it's if it reaches 0, then it stops. Right. This is more straightforward than the other one. Okay. Yeah. So 3, 2, 1, lift off. Then. So we also have 4. 4 is yeah, a while loop. You can have any condition, but you have to do the increment or decreasing yourself. But yeah, so you basically index need to be smaller than 5, because otherwise you have a panic. It's like it go beyond that. And then start with 0 every time the index press 1, so you just go through it here. But it is something, and then you write it here. This is how to use the print line if you have something like that. It's more complex, then you can put the contents of the curly bracket outside, I guess. So yeah, it's an index, so you take off these 10, 20, 30, so on and so forth. But you can use it in the for loop. So for element in A, so it would just go through A in an array in a for loop. You can just put element here like that, and then, or you can declare range like that, and REV, I guess is reversed. Let's give it a try. I think it's 4, 3, 2, 1, and then lift off, I think. Oh, actually 3, 2, 1. Oh, the last one doesn't count. Okay, the last one doesn't count, so this one is actually, yep. Reverse it. So normally it will be 1, 2, 3. This last one is not going to be included. But because we reverse it, so it's 3, 2, 1 instead of 1, 2, 3. Cool. This is a bit nicer. This is better than like this. This is like, what's going on here? I don't like that. But this one is much easier. So cool. Oh, now we can try to do the following. We can converge the temperature between Fahrenheit and Celsius. Okay, let's do this exercise and call it a day. Print the lyrics. Really? I don't know the lyrics. Taking advantage of the repetition in a song. Okay. Okay. Challenge of the day. Let's finish this off with this. So how to convert how to convert between how to okay, so this is the formula, so let's create a new one. So this is so cargo new temperature. Okay, so now we have temperature. So what we gotta do is go to main, and then we can have a, do we have to use the input output? Okay, so maybe let's make it easier. We just hard code it. We'll print it out at the end, but we'll hard code it. Temp in what do you want? Fahrenheit. Oh, in Fahrenheit or Celsius. So let's put in C. Oh, what's that? No, temp. Go. Okay, so imagine my American friend give me a Fahrenheit. I want to change it to Celsius. So let's say 32. So it's actually 0 degree if I remember correctly. So let's see if we get 0 degree. So we would this we have to let, and then so it's fine. I hard coded it. I need to do a semicolon, already fixing some problems. And now I want to have a Celsius temperature. So if I do let temp in C equals to temp in F. So what do you do? Minus 32 and then times minus 32. Oh, I want to make this a float, right? So let's try this. So maybe I'll make this a float as well. Want to maybe dot 0 here. So this is minus 30. So yeah, dot 0. I think this is fine, as long as I have the 510 divided by 9, right? Oop. I hope it's fine. I don't know. Let's print this out, shall we? Okay, let's try. Let's try the most simplest one first, and then, oh, I think I'm missing some semicolons. So yeah, we would try step by step because I am very dumb. So, okay, I can't do it like that. So I don't have to do that. Okay, it's different. Oh, you have to dot 0 because this is a floating point, right? I make it a floating point, I guess. Yeah, now also complete. Also, everything needs to be very clear. Okay, fine. It's okay. We are learning. So now it's 0 degree, but there are something that's wrong to the snake case. So it doesn't like if I capital it, so it's fine. I can make it small. It looks a bit weird, but it's fine. Okay. Now it doesn't like it because okay, because now it has been changed. So let's change this like that. Okay. So now I have that. What if I create a func to do it? So if I change it into a func, then I have this, and then I would have I would return to I would have a variable temp, which is a F32. Now I have that, and then now I would have this. Alright, I will have to return this, so I don't want the semicolon at the end, I guess. So now I can do it like that. Oh, Nope, that's not what I want to do. Okay, so this will be temp in C. Then this time I don't even need this. Let's just put this like that, and then I can do 32.0 like that. Will this work? Will this work? Will this work? Will this work? Will it work or not? Okay, something's wrong. I'm not finding the scoop. Oh, yeah, now it's called temp. Sorry about that. Yep, it works. So I guess the next step is that people can like have an input and stuff, which I can totally copy from the guest game, I guess. So I need the standard IO, and I have to convert it. So do I want to do that? I think I can quickly do that. I'm a bit obsessed right now, so I need this. Needs to use standard IO, and then what I can do is to have this IO standard, so I have to have a string to do this. So I would need to have the user input, so input, right? The string, so this is input, and then now, or maybe I just call it temp for now until it complains. Then I have to convert this into what I want. So I would copy what the guest game does, which is like this, and then yeah, I think I would just use the dot accept to handle this. So I would copy this for now. So here, so this is temp. I want F32, and then I don't need the match. I just use the temp.trim pass accept. Need to be not a temperature, not a floating point number, not a just not a temperature. I don't know. It doesn't matter. And then now I have temp, and then I would so this is temp. Yeah, this is the same, but I think because different scope it may be fine. So let's have a look. I think I make a lot of silly mistake like missing semicolon and stuff. Also, I should break it into different lines, but I'm lazy. Let's see. Okay. Accept, expect. Okay. I'm too used to accept. That's the like the catching the try and accept in Python. So that's why. Oop. It says it's running. Oh, baby, it's expecting my input, so I put 32 and a 0. Cool. What if I put something else like 46 degree and a 7 degree? It's very cold. Very cold. Like winter in Hong Kong is like 7 degrees, something like that. It's not too cold, I guess, here in the UK. Yeah. Okay, so maybe if I want to make it nicer, I can just print out like give me a temperature in Fahrenheit or something like that. So I guess I can just do it like that. Give me a temperature in Fahrenheit. Alright, let's try this. Oop. Semicolon nightmare. Okay. I think I'll get used to it after a while. Okay, Fahrenheit, so 56. It's 13 degree. Cool. Well done, me. I think this is exercise 1. Exercise 2 is Fibonacci number. Nth Fibonacci number. So you know, it's like you just like add them up until the end. So let's see. I think I'll start something like, again, just start hard coding it and then adding the IO or whatever if I want, or maybe I don't want. So cargo new Fibonacci. I don't know how to spell that. So let me cheat. Okay, oop. Let me cheat. Fibonacci. I think it's a Italian name, isn't it? Fibonacci. It sounds very Italian to me. So now we have Fibonacci. Hello, where are you? Okay, here. Nope. Main. So what I would do is to so for example, let enum equals to 10, let's say, and then I have function fibon. Being very lazy, fibon, and I take in a number x, and I use do I want 8? It's like, don't generate a very big Fibonacci number, you will go crazy. So I would end up having a U32, let's say. Is it big enough? I don't know. Yeah, if it overflows, then it overflows. So now, so I have that, and then so I would have, I would need to have 2, right? So I would have to have the previous one and the new one. So I'll have to have x1 and x2. And it would get, it would get bigger and bigger. I think you just make it 32 is fine. Yeah, it's just n-num can't be very big. Don't put something very big in n-num, please. x1 and x2. U32 as well. Let's put it this way. Or do you want a whole list, but it's just 1/n? Huh, interesting. Okay, so let's try to do it this way. x1 plus x2. Right, and then, so I need the first, so 4, so for count in, so it counts 0, 1, 2, 3, 4, 5, so 0 dot dot enum, right? No, actually the first one is 0, the second one is minus 2. Huh. So if enum, so if enum is less than 3, then I would just give them, so 0, 1. So no, let's use a match enum to actually, yeah, if and if else is better this way, because then we have bigger than, which is super complicated. I don't like, I don't know. Enum is equals to 1. So actually it's smaller than 1, then I would do a print line not a better choice. That n need to be bigger, need to be than 0, and then else if enum is equals to 1, then print line. I can just hard code it. This will be 0, so it'll be 0, 1, 2, right? How does Fibonacci number start? Fibonacci, I think it's 1 plus 1, I think. 0, 1, 1, so it will give you 0. So print out 0. I don't care, I just print out 0. Else if, so if it is equals to 2, if n is equal to 2, then it will give me so let's not do this for now. Let's just handle this case first. Let's give you 1, right? So let's try something like 0. So it should panic, right? No, it should give you, so oh, forgot the macro. Okay, save. And oh, you can't do it like that. Okay, it's okay. Let's do it like this. Oop. No, actually, yeah, I think, yeah, it's like this. Yeah, it will become a string. Let's do this, and then do this. Okay, it's fine. I forgot the semicolon as well. It will complain later. Yeah, this will do. Do that, and then it's never been used. It's fine. Let's put it like this for now. I think that right, or put it in front. You need to put it in front, I think. Let's do it like this. Alright, I'll get rid of that. Let's see if it works first. Yeah, it works. Not at the end, so let's give it a 1. See if it see if it works. It will give you a 0, so if I give it a 2, then it should give me a 1. Yeah, so now it's the rest. So we need to use the VBON if it's rest. So yeah, so let's do else. So for count in, well, actually I'm not using count. Maybe can I use the underscore in the, so I'm counting from 3, right? So the third one, but I'm 0 indexing, so 0, 1. So I can use like 1 indexing, right? So 0, 1, like the first 2 is already sorted. So I'm going for the third one, because and then dot dot and num plus 1. So it will count, and then this will return a no, then you have to store it, right? You have to store the last 2. Yeah, so you have, okay, so I have to be like let, and then and mute, so last, so num, so before and before, so before before is 0, and let's mute before equals to 1. Okay, so and then you do that, and then you would so you would be before equals to before, so before equals to before, and then before equals to before. So I need to count because I have to I have to return it at the, no, actually if I calculate, then and at the end I just return before, right? So after the 4, and now I just return before, I think. Yeah, so before we're equals to VBON, no, then I'm missing 1. No, I have to, I have to do this first. So now equals to it's super funky. I think there's a better way of doing it, but now equals to before and before, Okay, give this 2 and then you add it up together and give me that. Actually, I don't need the function now because then I have the whole thing. Yeah, I don't need it because yeah, that would be a recurring thing, but I'm doing it in a for loop, so that's different. Okay, now equals to before plus before. Then yeah, that is like more like a recurring thing. I think there's a textbook example of doing it, but I'm just doing it now this way. And then before equals to now. Right, and then I just give before at the end. I need to let now equals to this is fine. Oh, actually, I can just let the new one every time, but yeah, I don't know. It's super funky. I don't know if it will work. So let's try it to be like 3. Or you can write a recursive function to do that. Oop. I can't do it like that. Oh, forgot the space. Forgot the space. Let's try that. And expecting. Ooh. Ah, right. There's no else we just ended printing it out, right? Print this. Print line. Okay. How the previous error. So remind me how to do the for again, right? In dot for let's do this. It still complains. Maybe I can't. Or oh. Okay, so apparently you can skip this. Huh, interesting. Okay, I didn't know that. Ah, spelling mistake. Okay, you give me a 1 for 3. So what's the 5th one? What's the 5th one? 1, 2, 3, 4, 5. It should give me a 3. Right. Give me a 3. What's the 10th one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 34. If I say type 10, it should give me 34. Right. Ah! What am I doing? Yep, okay. So it works. I guess you can write a recursive function, which was what my brain was trying to do before, but then I end up writing a for loop, which is fine. Okay. So moving on to the next one. Lyrics. I need the lyrics. Okay. What's going on here? I think I can create a list with all these like different things. So first, second, third, all these can be stored in an array, which will have sent to me, and then all these different things. They're counting back. So, okay, so you need to have the date, and then you have the stuff. So I need 2 arrays. Yay! Okay, so let's do this. So cargo new Christmas. Okay. So let's do Christmas. Christmas is here. Close main, and then I'm getting all of this. So let me clear this up. Okay, let's clear it up. Okay, so on the first days of Christmas, so I need. What have I done? Okay, I will need date. Days equals to. So this is an array. So let days, that would be a string. Is it string like that? Or do I have the capital? I think I have the capital string, and it needs to be 12 of them. Semicolon, right? It's semicolon. So like that. Let me double check. I forgot. Totally forgot. Let's try to compile this first. Then I would see. So first, second, third, and then until the 14th, 12th. Okay. So oh my god, a lot of typing here. First, second, third, fourth, fifth. So if there's any typo, don't mind me. I am just want to quickly do that. 7th, right? No, I can't see. Okay, 7th. I should break it into 2 lines. I think I have soft wrap. It's fine. It's ugly, but I hope it works. And once we have the formatter, then it will be fine. No, 9th is correct like that. 10th. Okay, I really have to break it. I hope it won't complain if I do that. 10. And then 11th. 12. Okay. Semicolon. Whew. So print hello world is fine. You can print hello world or print. Can I just print days? Maybe I can. I don't know. Let's see. Oh, expected string. I found the end string. What should I do? Is it a end string or is it how to declare a string? How to check what's the different type of things? I need to do something like no, not this. I don't know the string type yet, so I'll do some googling. Rest string type and string. I guess we're using and string here now. True string type is restored as a vector of type. I don't know. I haven't learned the string type yet, so I'm just going to do whatever I was told by the compiler. And or maybe I just don't declare it. I think it's fine. The compiler will take care of it for me, hopefully. Let's do that. No. Days. I can't do this. Cannot be formatted. Okay, it's fine. It's just let's just do this. Let's just not print it out. Let's just see if it works. And oh yeah, it's in front. What do I think is at the back? I don't know what I'm doing. Okay, it works. Okay, kind of. Okay, so let's do the stuff. Let's do the stuff. So these are the stuff, right? So stuff. So let stuff equals to. So I would use underscore stuff for now, just to make sure everything's fine. I have a semicolon at the back. I guess this one I'll have to do it like that because it's long. So a partridge in a pear tree is oh no, I haven't copied it. A partridge in a pear tree. This is not a very good website. Let's find a better one. Christmas. Oh, okay. Wow. for the video as well. Right, okay, fine. I want everything here. And do I use N at the first one? No, I don't think so. Yeah, no. So N is like when I have more than one edit at the end. It's just like a and then I have a capital letter. It's going to be very complicated. Okay, I'm gonna cheat. I'm gonna ignore the N. Because it's just getting things very complicated. Yep, then I have 2 turtle doves. Yeah, I won't have the N, but it's fine. Just want it to be much simpler, and I ignore the punctuation as well. It's driving me crazy. Yes, string and end string. Yeah, I hope they'll teach me. And debug, to get a debug instead of display output. Okay. Yeah, I'll give it a try next time. Right, so 3 French hens and 4 calling birds. No, all calling birds. 5 golden rings. And then 6 geese are lying. Yeah, we don't like. I feel like I'm missing out because, like, you know, I grew up in Hong Kong, so it's like a mix of a Western and a Chinese culture. Of course, my parents are. So yeah, like, we are like Chinese descendants, so like we don't really do like traditional Western Christmas kind of thing. Christmas is usually, because I go to a Catholic school, so we would have like you know, Christmas mass and things like that. We do have Christmas party for the kids, because also kind of like celebrate after the exam, so we kind of like, oh yeah, we love Christmas party. But yeah, and then so yeah, I don't have all this like very the traditional Western Christmas kind of thing that I don't have growing up. Yeah, because when you get to teenage age, like Christmas Day is just a day that you either go out with your date or you go out with friends. that's what we do in Christmas in Hong Kong. So okay, I have this too. It looks a bit weird. Is it the format? Yeah. Why is it like this? Oh, I'm trying to fix it. Yeah, why is it so weird? So there's 4 space, right? One. Hang on. 1, 2, 3, 4. So why is this crazy? Yeah. Okay. Let this be it. Sorry about the formatting. It's very weird. I hope the formatter will fix it in the future. I hope. Okay. So now I have to print this song. So on the day of Christmas. So so first of all, I have to print out each verse. So I have to print out 4. So I have to do it 12 times in. So it needs to be 0.12, and then do this, and then what do I do? I know that at the end I would have a space, so I guess if I print an exclamation mark, this will give me a end of line. If I print nothing, I don't know. Let's try. So on the first days, on the X days of Christmas, so print. On the now I have to have the count. So count. So month, no day. So now I have the days. I have the stuff. So day of Christmas. My true love gave to me, so that will be the second line. It's fine, don't worry about it now. So this one I need days, and then day, right? And then my true love gave to me, I'll just copy it and print. Okay, like that. So I should print out the stuff, which is another loop. So for thing in stuff. No, for in okay. So no, I can do day in days, right? Yeah, that's better. I was stupid. Okay, day in days. So we just day here, and then for thing in. So I would need to have from. Oh, but then I have to count the no that was better. Day is a number. Then I can do the counts. Counts this, right? So I have to do it like this. Okay. So thing in so the range should be from 0 to the day plus 1, right? Day plus 1. Do I have to have the bracket and stuff? I forgot. Oh my god, I totally forgot. Let's cheat. Okay, I'll do this. Oh yeah, I can have the plus 1 there. No problem. So if I do this, then I would print line exclamation mark. Now it's like in my blood. Okay. So I print line the stuff. And then thing, right? I hope it's right. Thing, they print out all those. Okay. Let's give it a try. I'm a bit stuck. Okay. What's going on? Do it. Whoa, there's a lot of things. Let's check the last one first. Well, there's the typo and stuff. Oh, it needs to be in reverse order. Yes, you're right. Let's do it in reverse. Rev. Okay, let's try this again. And then the on is not capitalized for some reason. Let's fix that. Okay, on the Thursday of Christmas, my true love gave to me. Yeah, so like except the end, I think it works. I think. Yeah, let's check the first one. Okay, it kind of works, except that we don't have an N, which is meh. But I think we get the idea. We have practiced a lot for what we know for now. I guess for the N, it's not too difficult. You just like, maybe if you ignore the capitalized thing, right? You can just say like here if day is so yeah, so like if day is 0, then you print without the N like this. If it's then like you if the day is 0 and the yeah, you can check it or something. I'm sure like in the future we can easily have a way to do it, but I don't care for now. I'm a bit tired. So yeah, I think we are doing well. Well done me. Well done you giving me tips. So thank you so much. Format on the save action, exactly. Cargo format, manual to format it. Yeah, no, although I know. Sorry, you have to sit for me having like all these awful like formatting thing. I know, but I don't want to jump ahead, right? I know you give me tip, you tell me how to debug, you teach me how to use the formatting. I think it's cool. Thank you so much, but I want to save the good bit in the future. So I hope in the book they will teach me how to use it. Yeah, I guess you just need to do like cargo format, right? Like that's what you said. FMT. Yeah, you see, it's like it's beautiful now. It's beautiful. It's amazing. It's so good. But yeah. And then I guess you can create a hook to auto format it on save, which is amazing. Like, I love it. I love that Russ gave me all of these, and yeah, I would figure it out in the future. I hope, I'm still a baby. I'm like today years old, my Russ age. So, yeah. So thank you so much for sitting with me for so long and see me struggle. And maybe you like it. Maybe you remember like all this time when you start learning Russ and all. So we have a lot of things to go, right? Oh wow, this would take me a month to go through all of them. I hope it's faster than that, but I'll see. I'm now actually looking for my new role. So let me know if you have anything exciting going on. Go to my website. My LinkedIn is there, so it's two-step, but you can find my LinkedIn and drop me a message if you're hiring. But I have a lot of time now, so I can learn Rust. I am enjoying it, and so hopefully we don't have to like spend more than a month to go through all of them. But who knows? Who knows, right? I'm not giving up. I will try to finish the book at least, and then maybe we'll do some exercise. Maybe we would play the wrestling things, wrestling. So much fun and do all of those. But anyway, yeah, that's it for me. And if you follow me on Twitter and stuff, hello, yes, yeah, thank you so much. And yeah, so I'm if you follow me on Twitter and all stuff, I'm still doing a lot of community work for the Python community, and yeah, so part of the thing I'm doing regularly now is to still do like community work, but also looking for new role and learning Rust. So this is what I'm doing right now at the moment. So yeah, follow me on Twitter for updates. Make sure you subscribe to my channel because I don't have a schedule. Whenever I go online, then like if you have the notification on, then you can watch me suffer, and have fun. And thank you again for sitting around with me, and you know, I hope you like it, and tell your friends. They can watch the recording and stuff and things like that. See you maybe tomorrow. I will try to do it more often, maybe like hopefully every day, but if the day got really busy, if I'm traveling, then I can't. But hopefully I'll see you tomorrow, and have a good rest of the day. So see you. Bye.